Hello everyone, welcome back to the channel and welcome to our ASE test prep series. Today I'm here with my co-host Daniel Aney. We're going to be checking out some questions for the A6 ASE exam.
Let's get started. All right, now before we get started, I'd like to talk a little bit about who this series is for and who would most benefit from watching this. So could you fill us in on who should be watching these?
We're making this series to help some of our students, hey guys, to get prepared for their upcoming ASE exams, for those choosing to take them, and for anybody else in the YouTube universe who's interested in taking an ASE exam and would like to get better prepared for it.
Yeah, I think that's a good way of explaining it, but I also think that it's probably best suited for people who have some experience, right?
Yeah, no, that's a great point because we're not going to be covering all the little tidbits of design information and theoretical type of information. ASE specializes and focuses on diagnostic questions. So that's going to be our approach. We'll be reading questions, talking about why some answer options are not correct, why some are correct, and the information in between. So this is going to be quite confusing for anybody who has zero automotive background, but I'm sure you learned something along the way anyways, but just so people stay.
So I would say students or people who are actually actively in the industry who are looking to get ASE certified, these videos would probably be perfect for them.
Perfect way of putting it.
I love it. Let's get started.
Yeah. All right, let's check out our first question. What is the most likely cause of a windshield wiper system that only works on low speed? A, a blown fuse. B, a faulty multifunction switch. C, a loose ground at the wiper motor. D, an open park switch.
All right, so right off the bat, a question like this, I like to start like all of them and read each possible answer and don't discount anything right away. I think a lot of times people get in a rush and they will kind of instantly look for something. They'll read the question and they're looking for something. So my thoughts on this one right away is that it is working. So that's the first clue I'm looking at and say, okay, well, they say it works. It only works on low apparently, but it works. So that will cross a lot of things off the list, right?
A for the first example, right?
Totally, right?
I like to kind of think of each one as like a true false, right? So like you said, you're looking at each question or each answer individually. A, true or false, could a blown fuse cause this?
Sure.
They didn't give us a lot of information, just that the system works on low speed. So I'm right with you. A blown fuse, just generically saying it like that, is going to cause the whole system to not function. So that would be a false.
Cannot be correct. So let's get to the next one, and it says a faulty multifunction switch. Now, the multifunction switch is the one that we're actually interacting with.
Controlling what speeds.
Right, which sounds like it's plausible, right?
Yeah,
this could happen. So let's keep that in our back pocket and let's keep going. What's the next one?
C says a loose ground at the wiper motor.
So let's think about that. A loose ground, that's an interesting one. It doesn't say it's disconnected. It says it's loose. So what is that going to do to this circuit?
I mean, it looks similar to me like the A answer, which was like a blown fuse, is that a loose ground may cause intermittent problems, but or a problem overall for the system, but it's not going to give us some speeds and not others.
Yeah,
so
no, I like
again,
that.
with the, it works, but only on low speed, I don't think that a loose ground is going to cause that.
That's a great point. A loose ground is going to affect it in all modes of operation by significantly increasing resistance. So yeah, I love it. That can't be C. And last but not least, we have D, an open park switch. Now, this is a tough one. I would say this is the one that they're throwing in there to see, do you really know what you're talking about? Do you know what a
park switch is?
Yeah, and a park switch is, it's built into the motor itself, the wiper motor itself, and oftentimes what that's doing, or all the time, is that if you turn off your wipers while they're in the middle of their operation, we need to let them remain on and park. So we actually need a separate power circuit separate from your multifunction switch to continue to power the wipers to allow them to get to the park position. So in fact, if you had an open park switch and you turn your wipers off, they would stop, well, wherever they are.
Right, yeah.
Now, maybe you don't know that. Maybe you don't have a really in-depth knowledge of that circuit, but we should still be able to answer this one right. That's why we always say, never panic. There's usually a way, even with limited information, to answer these correctly. So the best answer, of course, is going to be
the faulty function. A multi-function switch. Yes, I've been having a hard time saying that. But right, let's say I don't know what a park switch is, the fact that there is an open, right? So what I tell my electrical students all the time is if you understand the base, like you have good, solid theoretical knowledge of how electricity works and your basic faults, you know, your opens, your shorts, high resistance versus low resistance type stuff, then it doesn't matter what circuit you're looking at. You don't even have to know what the circuit's really for. And I use the example of you're looking at a circuit for a continuum transfunctioner. Could an open cause a blown fuse? It doesn't matter that this is for time travel. This is, can a blown fuse or can an open cause a blown fuse or not type of situation. It doesn't matter, right? I don't have to know what a park switch is, but I do have to know what an open is, and I have to know that an open circuit's not going to allow the circuit to function at all.
Yeah,
right?
and good basic fundamentals will answer most of these questions, and that's what we're going to find. So let's continue on to the next question.
The windshield washer system does not operate when the switch is depressed. A voltage test was performed at the pump motor while the switch was depressed, and 13 volts was measured. What is the most likely cause of this problem? So a couple of things here, right? One, they told us the problem, which is that the windshield washer system does not operate. So we're assuming squirter's not squirting. And we are also seeing that they gave us a voltage reading of 13 volts at the pump motor. That's important because even though we haven't read any of the questions, or I'm sorry, even though we haven't read any of the answers yet, right there, the fact that we have voltage at the motor tells us that we should have no opens up to the motor. We have continuity up to the motor at least.
What we do know is that the squirters aren't squirting, and that's a problem.
That's a problem.
So let's get into those possible answers.
And they also mentioned what is the most likely cause. So that could insinuate that there might be more than one possible cause, but which one's going to be the most likely?
So we want the best answer here. We
The
want to get
best
those
one.
squirters squirting again. Let's get into it.
A faulty washer pump switch. Let's
Okay.
go. Should we go through each?
Yeah, let's dive right into that. Now, you know, I think right off the bat, that's an easy one to discount because we did do a test here.
13 volts.
13 volts are
at the
available.
pump motor, so we know that the switch is switching.
You know, I'm thinking the switch is doing its job. So let's take a look at B.
I can tell it could have been a ground side switch, but I'm just fucking around now.
Wow.
All right, listen. Don't add any information to the question.
Yeah, you want to get them all wrong. You start doing that.
That's exactly.
Okay.
Yeah, that's exactly.
If you want your squirters to be squirting,
then don't add anything.
Just use the information they're giving you.
So switch seems like it's out because we've got voltage at the pump motor. B says a faulty washer pump relay.
You know, and this is very similar to A, in fact.
Similar situation.
Hey, we've done a test. We see there's voltage available. So likely that relay is working properly.
Right. C says an open wire in the washer pump circuit, which before, that's why I like kind of breaking down the question. Before I'd even said this was an option, I mentioned it can't be an open in the circuit because we have voltage at the pump motor, right?
Yeah, so this is another one that's just some basic fundamentals. And the last option is a faulty washer pump motor. Now we have power to that motor. Now, is there a good ground? We don't know. Doesn't matter. We're just working with the information they gave us.
Yeah.
And is that a possibility? 100%. We could have power going to this motor and the motor not functioning, right? Or the squirter's not squirting, as we would say. So in this case, another
squirter's broken.
Yeah, another very simple question, but if you go too quickly or you panic, you can even miss these easy ones. So we got to take a deep breath, look at these one by one, and it's usually a pretty simple solution.
Yeah, got to the bottom of it.
Let's check out that next question.
All right, so our question says, an inoperative sunroof is being diagnosed. A blown fuse for the sunroof is found. Technician A, my favorite kind of questions. Technician A says the cables should be checked for a binding problem.
Now, real quick, I'm going to stop you because this is what I do when I answer these, is we stop right there and we try to answer that portion of it.
Each technician, is its own question. I like that approach.
If we continue reading, we are going to start confusing ourselves, and our brain can only really process one thing at a time.
Yeah.
So I prefer to stop right there. Don't look at that extra information that Tech B. Let's investigate Tech A. So we know in this case we have a blown fuse.
Right.
And Tech A is saying, hey, we should check these cables for binding. And this is another question where maybe you've never worked on a sunroof. That's okay, as long as you understand the basics.
Keyword binding, right?
Mm-hmm.
Yeah.
So we know that motor, if these cables are binding, that motor is going to be slowed down, perhaps even stopped.
Right.
And if we have a little basic electrical theory, we're going to understand that that's going to cause a drastic or dramatic increase in current flow.
Right.
And of course, increases in current flow blow fuses.
Right.
So right away, I would stop there and answer that and say, hey, A is correct. Let's now move on
to Tech
to
B.
Tech B.
Yeah. No, I like that approach.
All right, let's see what Tech B says.
Tech B says that the motors should be checked for a shorting problem with an ohm meter.
All right, what are your thoughts on Tech B?
I'd say keyword is shorting or keyword shorting problem, right? So they're saying that we should be checking the motors for a short, essentially, and we're looking at a blown fuse. Blown fuse and shorts go together like peas and carrots.
No, I like it. This seems, it's very plausible, right? We could have a motor that has some sort of short, in which case, of course, we will result in a blown fuse.
Right.
So another simple one there.
Yep.
All right, let's get on to that next question.
A late model vehicle is being diagnosed for an inoperative heated steering wheel. Technician A says that a faulty clock spring could cause this problem.
Well, let's stop right there.
Yeah. Yes or no?
Let's investigate. So what do we need to know to answer this question? And this could be a tricky one, right?
What the hell a clock spring is.
That's a strange word. I don't know what that is. So this could be very difficult. And I think
to answer this question without knowing that would be
sure. And
pretty
you know,
tough.
honestly, depending on who you work for, maybe we have some Toyota technicians out there or technicians from different manufacturers. Some of them get very specific terminology. Toyota's notorious for this. You know, Ford for many years made up their own names for a lot of things. And I've run into this before where people will take ASE tests and not understand the terminology. Now, a clock spring could also be called a spiral cable, and sometimes they'll use other terms as well. So we have to be aware of this terminology to actually answer this properly. And what is the clock spring?
The clock spring is your generic term for the spiral of wire inside of the steering wheel that allows an electrical connection for any steering wheel controls to the rest of the circuit. So I can turn this way and I can turn this way.
Wow, apparently. Now, the clock spring is very important because we have things like our airbag in the steering wheel.
Probably the most important thing, right?
We never had these prior to airbags, or we didn't need them per se. There's ways of hooking a horn up without a fancy clock spring. But when you have an airbag, we need a very reliable connection at all times to the steering wheel. And that steering wheel is constantly moving. Obviously, it's turning both ways. And yeah, exactly. It's doing that. And over time, you would think that, you know, any kind of wire would end up breaking. So they have a special device called a clock spring where it's this wound up cable that is designed to do that. Yes, it's designed to do that. Exactly. So back to our question. Possibly we could have the current for the heater in this vehicle, the heated steering wheel element, going through the clock spring. This is the thought here. And that does make sense. If you're going to be hooking up wires between a steering wheel, which is going to be turning constantly, and a vehicle, likely it's going through that
pretty much
spring.
Everything in the steering wheel is gonna likely run through it, right? So
100%.
Radio controls,
sure,
your horn, obviously
sometimes
your airbag,
you
like
might even have
about.
An integrated wheel position sensor into your clock spring as well. Toyota's known to do that. So there's a lot of stuff going on in there. So what would we say about Tech A? Is this a possibility?
Tech A absolutely sounds like a possibility, right? If that clock spring is faulty, then we may not get power to that heated steering wheel. Now, we're looking at the ASE question. As a technician, you'd also likely notice that none of the steering wheel controls work at that point, right?
And you'd probably have an airbag light on as well.
Likely an SRS light on there too, yeah.
That is assuming that every wire in the clock spring has broken, though, which is probably likely. If one is pulled out or broken
one breaks,
or snapped,
yeah. But
likely
I mean,
they all work.
you know, and likely we're looking at some sort of connection fault in the connector unless some work was done in the steering wheel and it wasn't timed
and
properly,
that's certainly
right?
true. I used to, if I had a car that came in with an airbag light, I would push the airbag to honk the horn to see if that was also inoperable, just to see, okay, is this a possibility?
Right. And I mean, but again, these are all side notes. We don't want to add anything to the question. There could be many things that happen. Connection, it could be a pin fitment issue. We don't know. But we do know that the heated steering wheel is likely going to be running through the clock spring. So therefore, a faulty clock spring can cause an inoperative heated steering wheel.
All right, now let's check out Tech B.
Tech B says that the steering wheel heater grid can be replaced without removing the steering wheel.
Okay,
Interesting concept.
That's just insane. If there are any technicians out there who are replacing steering wheel heaters, good for you. But likely you're going to be replacing a whole steering wheel if that does go bad.
I've never seen one sold separately from the steering wheel.
Me neither. And that's the thing. So likely you'd be replacing the whole wheel. So this is a bit of a dumb question, but you're going to encounter those.
It's an interesting part of the question too, just because you don't see ASE talk about design features so much like that, which it's interesting, but doesn't mean you're not going to see it, and that's why we're covering it.
The thought would be you're going to, take the leather off and put a new, and resew it.
Stitch it.
Somehow I don't think so. So best answer here, we're going to go with what?
Yeah, I think Tech A is likely going to be the best answer for us. So.
I'm with that.
All right.
Ready for that next question?
Yeah.
Let's do it.
All right. So this next question has a little diagram for us.
Which is going to be right
so
there.
Somewhere in the floating abyss. As you can see in the provided diagram, we have a voltmeter, looks like a fluke, that is connected in a voltage drop manner across the light, and it looks like we have a 9-volt drop across the lamp. Now the problem is a 12-volt system, so right off the bat, before we even read the question, we know that voltage is being eaten up somewhere. So let's take a look. It says the circuit in the figure above is a 12-volt circuit and the battery is fully charged. Technician 8 says that the switch could have burnt contacts.
All right, we're going to stop right there as usual and try to investigate Tech A. Now, I see you already analyzed the diagram, which sometimes I do as well, especially very simple diagrams
just the
like
look-see. You're just kind of gathering. You're not making any conclusions. You're just seeing information that's provided.
Yeah, now if it's a dramatic diagram, especially if you guys are going to take an L1, don't do that. If it's something small, sure, take a peek. A lot of times you're going to be looking through just a bunch of nonsense. We want to go right to what we need. In this case, we're saying that the switch, which we see in our diagram there, could have burnt contacts. Now, the lamp is working, we can see in our diagram, and we do have a 9-volt drop. So what would happen if we had burnt contacts at our switch?
It's a weird question.
It is.
Just because when we say burnt contacts, what does that mean? Does that mean we have open contacts? Does that mean we, possibly have some sort of loose connection on the contacts? So this is one where it's very easy to overthink.
Certainly is.
But I think if ASE is telling you burnt contacts, to me, I am going to translate that as likely open contacts. If they said corroded contacts, that'd be something different, but they said burnt contacts. What do you think about that?
Well, this is a tough one. You really are trying to get in the mind of, well, who wrote this? And what I like to do when I'm having this issue looking at a question is I think, what knowledge is this question testing? Because when you make a question, you're trying to prove whether or not someone has specific knowledge. Right. At least if you're writing questions well, and most of these are. So in this case, what we're trying to understand is what would cause this lamp to only drop 9 volts? Now, of course, we'd like the lamp to drop all the volts and be nice and bright. In this case, we know we have high resistance somewhere, but what I think they're getting at is, do we know that high resistance on the power feed side, the switch side, or high resistance on the ground side would both result in a lower voltage drop? So the way I would read this is they're trying to say, okay, we have high resistance at the switch due to contacts that are burnt, and would that result in a lower voltage drop for the bulb? And the way I would see it is, yes, it would.
Because it could be pitted. So we're looking at like a loose connection, right?
Essentially, yes. And that's what would cause switch contacts to burn, in fact, would be loose contacts, which would cause high resistance and localized heat. which would result in them burning or becoming burnt.
Right.
So I would say that is a possibility. Now, if we look at Tech B, it's essentially the opposite. It's saying what? It's saying we could have a poor ground. So now we're looking at the opposite side of the circuit.
And they said poor ground connection. So
Mm.
again, what do we translate that to? Poor ground connection could be a loose contact,
Certainly.
which again, high resistance.
High resistance, corrosion, loose, whatever the case is, we know in this case, or Tech B is telling us that we have high resistance on the ground. And what we should know is if we have high resistance in a circuit such as this, that we are going to have a voltage drop over that resistance,
Yeah.
which will reduce the available voltage for our lamp. So best answer here,
Both.
I think we're going with C on this one.
Yeah, this is a tricky one though, and I think this one could get some even some very I'd say experienced technicians because it's all in how you translate burnt.
I agree.
Right?
And if you think burnt means that they are open, you would likely get this wrong because the way I read burnt is just what it says. Imagine contacts, and many of us have seen what burnt contacts look like. They do fail in that fashion.
Yeah.
And you will tell that they've gone hot. Usually you see a lot of darkening of the contacts, maybe
Right.
some pitting due to the heat, so or the arcing that was going on in there. So in this case, I think the best answer is going to be C, and this one is a little bit challenging, right? Remember, we don't have to get them all right, huh?
Yes, just 70% of them.
70%, and that's what we're shooting for in life, guys. Okay, don't shoot for the stars. 70%. That's all you need.
Mediocrity. That was our last question, so
That's all we got.
that's all we got, folks. Hopefully, you guys found this helpful. Let us know in the comments.
Yeah. If there's anything else you want to hear, or if you want us to go in depth on some of these concepts, let us know because we can do that. Spend a little time on some of those more challenging questions, or go in depth as to things like the binding motor and why does that cause increased current flow. In fact, we could show you that.
Right. Yeah, we could in real time with tools. We could also go into things like available voltage versus voltage drop test, whatever you guys like. So let us know what you want to see, and we'll pick what we want out of it.
New videos every 5 years. So set your clocks.